Hi guys, myself Rutik Dakore and I am going to present an unsupervised machine learning project on online retail customer segmentation. This is my GitHub link. So let's start with project summary. The aim of this machine learning project is to perform customer segmentation for our online retail business. Customer segmentation involves dividing a customer into a distinct group based on shared characteristics, behavior or preference. By effectively segmenting customers, business can gain valuable insight and tailor their marketing strategies to other specific customer group, leading to improved customer satisfaction and increased profitability. Let's go to problem statement. In this project, your task is to identify major customer segments on transactional data set which contains all the transactions occurring between 1/12/2010 to 9/12/2011 for UK-based and registered non-store online retail. The company mainly sells unique all-occasion gift. Many customers of this company are wholesalers. Data description. There are many attributes such as invoice voice, stock code, description, quantity, invoice date, unit price, customer ID, and contact. So let's go over with importing libraries. So we will import libraries such as pandas, numpy, matplotlib, seaborn, and we will also get sklearn. We will first mount the drive and give a file path. Then we will use this file path to read our CSV file. We will check head and shape of our dataset. Let's go over the data wrangling. Let's check the data types and null values in dataset. Data type of invoice date is object, need to convert into date time. If invoice number start with C means it's a cancellation. We need to drop these entries. There are null values in customer ID and description. So let us check the null values. There are a lot of null values in customer ID and description. So visualizing the null value using heat map, we can see there are a lot in customer ID. Observation: missing values in customer ID and description column. So let's go over by replacing. We will change the date time to string. Also, if invoice starts with C, it means cancellation we need to drop. And checking how many values are present for unit price, that is 0. So after handling this, we will move to the feature engineering, which in short lets us collect the most important features. We will convert invoice date to date time, extracting month from invoice date, and here we have changed our date time into time, invoice date into time plus date. Let's go to EDA section. Here we will first check the column names and we will take top 10 product in from retail DF, that is description. Here we can see the top 10 product. Then bottom 10 in terms of description, there are top 10. Top 10 items in terms of stock code. So this was the basic EDA. We will you will see. So model building. What is model building? We will start with RFF model analysis. What is RMF? RFM, sorry. Recency, frequency, and monitoring. Analysis is a widely used customer segmentation technique in marketing and analytics. It helps businesses understand and categorize their customer based on three key factors: how recently they made a purchase, recency, how frequently they made their purchases, frequency, and how much they spend, monetary value. RFM and enables businesses to identify and target different customer segments with customized marketing approach. Why is it needed? RFM analysis is a marketing framework that we use to understand and analyze customer behavior based on about these factors. The RFM analysis will help a business to segment their customer base into different homogeneous groups so that they can engage with each group with different target strategies. Let's go to RFM. We will make an RFM data frame from retail DF copy. So we will copy this dataset into RFM data frame. We will check with the first 5 rows with dot head. recency, latest date, last invoice date, frequency, count of invoice, number of transaction, and monetary is sum of total. We will go over this. We can see the distribution of recency is rightly skewed. Also, distribution of frequency is highly right skewed, and distribution of monetary is highly right skewed. So we can see the all three are rightly skewed. Now let's visualize the distribution of recency, frequency, and monetary. We can see the distribution of recency, distribution of frequency, and distribution of monetary. So let's go k-means clustering to handle. We will import the libraries, and before implementing k-means clustering algorithm, we need to decide the number of clusters to put inside algorithm as input. So we will be finding the minimum number of clusters required by using elbow method. For recency and monetary, applying elbow method to recency and monetary. Here we will be applying recency and monetary. So we can see the optimal value for cluster came out to be 2. Cross verifying with elbow visualizer. Elbow visualizer also giving cluster 2. Silhouette score. Here we can also see the number of clustered is 2 in silhouette score. Now let's perform DB scan algorithm on recency and monetary. For frequency and monetary, let's perform k-means clustering. But before implementing k-means clustering, we also need to find clusters for frequency and monetary. So first let us go over applying elbow method and then DB scan. Here we can see the optimum value of cluster came to be 2. Cross verifying with elbow visualizer, and here elbow visualizer also giving the cluster 2. Silhouette score. So we can see that number of cluster is also 2 in silhouette score. Let's perform DB scan algorithm of frequency and monetary. Now for all three, recency, frequency, and monetary. So before implementing k-means clustering, we need to find a number of clusters. So first, elbow method for recency, frequency, and monetary. DB scan algorithm on recency, frequency, and monetary. We will check this with elbow visualizer. Here 2, and cross verifying with elbow visualizer. It is also giving number of cluster 2. Silhouette score also 2. Now DB scan for recency, frequency, and monetary. Here we find the estimated number of clusters are 2 and estimated number of noise points are 139. So let's move over to hierarchical clustering. How should we choose the number of clustering in hierarchical clustering? A dendrograph is a tree-like diagram that records the sequence of merge or splits. More the distance of vertical lines in dendrogram, more the distance between those clusters. We can set a threshold distance and draw a horizontal line. Generally, we try to set the threshold in such a way that it cuts the tallest vertical line, find the largest vertical distance we can make without crossing any other horizontal line. We'll first start with import, and we can see the dendrogram here. So the number of cluster will be number of vertical line, which are 2. So here we have completed our segmentation for online retail customer. So let's move to the summary and conclusion of this project. Firstly, we did clustering based on RFM analysis. We had 4 clusters / segmentation of customer based on RFM score, recency, frequency, monetary, and you can see platinum, gold, silver, bronze are RFM loyalty level. Later, we implemented machine learning algorithm to cluster the customers. So you can see with model name, data, and optimal number of clusters, all are 2. So Above clustering is done with recency, frequency, and monetary values. K means clustering, as all three together will provide more information. Cluster 0 has high recency rate but very low frequency and monetary. Cluster 0 contains 2414 customers. Cluster 1 has low recency rate but there are frequent buyers and spends very high money than other customer, as mean monetary value is very high. Thus generates more revenue to retail business. With this, we are done with our project. Also, we can use more robust analysis for clustering using not only RFM but other metric such as demographic or product feature. So, I would like to conclude my project. Thank you.